Good morning, everybody. Thanks for joining our marine seminar webinar today. Um, as you know, we're all locked down with the COVID-19. So here in Spain, it's about more than 6 weeks. We're working from home, and I try to do webinar time to time and keep you informed our products and also the resistive imaging techniques and different applications. Today, I will talk about a little bit how marine studies can be done. Actually, we will be talking about that how you can do resistivity imaging water environment, not only for marine. Can be when we say marine, can be like in the seaside and the deep ocean bottom studies and the river studies, the canal studies, and some lake and pool, as well as the borehole studies. All these studies can be done in the water environment or saturated zone, let's say. So I will show you how you can do this kind of studies today with our marine system, and also how you get benefit of this kind of the studies. And there are two major techniques on these in what we call it stationary studies and dynamic studies. I will talk about on these also today. So it's going to be like a very short presentation, and then at the end of this presentation you can also meantime type your questions, and I try to answer your questions at the end of this presentation. And if I miss anything, you can just email me back, and then you can also I can give you the answer later on through the email or through other different media. At the end of this today, I will also pull a poll that you can participate and give your opinion about what could be most beneficial for you our next webinar. So we can go through preparing that kind of the webinar in the future. Okay, I hope everybody can hear. There is no objection. If let me see, somebody's the okay. So far, no question. Everybody is okay. It looks like. So let's go through these marine studies. Some of you may have our marine system or SuperSting system. So our SuperSting system is like instrument, we have a 1-channel, 2-channel, 4-channel, 6-channel, and 8-channel SuperSting. So new generation SuperSting, what I call it, this new generation SuperSting with like a upgradable from 1-channel to 8-channel with Wi-Fi communications. Those new instrument is ready to do marine studies anytime you want. You don't need to change any firmware on the instrument. However, if you have older instrument, if you already bought it SuperSting before 2014 and doesn't have any Wi-Fi module on it, then you need to, if you want to do the marine studies, like a marine dynamic studies, you need to change the firmware of the instrument, put in marine firmware. So those has these old instrument you need to change the marine firmware when they do marine studies. When they do same instrument used for land studies, stationary studies, they need to change the firmware marine land firmware. Okay, for new generation SuperSting Wi-Fi, you just need to add module, what we call it marine module. So you simply add this marine module, and you can just tow for dynamic studies, you can just tow your sensor cable, which is like here. What you can see here is that the towing cable here. So this towing cable, at least for 8 channels measurement, is what we have it is the 11 electrode towing cable. So typically, let me just go highlight over here this laser point. Okay, here you can see the towing cable. So like what we have is the mainly this towing cable is we recommend to use the graphite electrodes. So at least if it is just 11 electrode, at least we recommend to put first 2 electrode, these graphite electrodes, and where the current injection will be go through it. So in this case, the electrode, if we use these all of them stainless steel, the current electrode mostly is start corrosive material on the top of the electrode, and then we got corrosion on the electrodes. So that will create noise, and it will eliminate less current injection, and also less sensible to receive the voltage as a receiver. So in that case, is you start measuring noisy data. So we recommend to use graphite electrode in the all water environment studies. And this module, and here you can see here's a marine Wi-Fi module. So it can be just connected through, and then GPS, external GPS as well. And here you can see is a tablet. So the tablet is for new generation marine application. We make easier to loss of the collection data, correcting the problem, controlling the navigation, many things. And I will talk about this shortly. This marine, I mean, this SuperSting using this um, Android applications, what we call it, marine log managers, marine managers applications. So let's just go through a little bit what general cases you're using. I know some clients, they do just for very shallow studies from the seaside, like monitoring leakage in the dam, and this monitoring leakage in the dam, and also is recently is people using it for the like a pond, for a mining pond, and mining the material they dump, and then they try to monitor and that for if there is any leakage in the linear. And they can also use this marine cable for stationary studies or dynamic studies, depending on the size of the dam, size of the lake, size of the pond. You can also map for fresh salty water intrusion if you're near shoreline or offshore. You can characterize sub-bottom studies, imaging water column salinity variations. You can do also mineral exploration, especially recently there are some interest to mineral exploration in the deep water sites. Locating freshwater spring at the sea bottom, that's also you can do with this for marine cable studies, marine studies. You can do distinguish between hard rock, sand, gravel, sealed clay. This is generally for like a dredging is also is commonly used for many clients mainly for shallow studies like harbors and canals, and this kind of dredging studies really helps for these companies. So typically a key feature of the system is um, you inject like every 3 seconds, and then you start much voltage readings. So for 8-channel version of our system, what you do is you get 8 level of measurement, but typically dipole measurements. So like a dipole allows you to get good data up to 8 levels. After that, we don't really get very good the dipole readings. In that case, is our system is developed for just 8-channel for 8 level of able to do good dipole measurements. So depth of penetration on these studies is all depending on the cable length, and the cable length is generally is if you're let's say if you have 100 meters cable, So you can reach about 20% of this cable length, so which means it's 20 meters of depth. So if you're in the very saline environment, very high salinity zones, then depth of investigation could be about 15%. And so you can consider, instead of going 20 meters depth, then you may be limited maybe 15%. That's only things is the affecting our depth in the marine studies. So like if you're very, let's say freshwater environment, in this will be about 20 meters. If you're very saline environment, the hypersaline zones, you can get like about 14-15% of this the cable length. Another issue is resolution on these measurements. So in all electrical imaging, including this marine, resolution is the half of electrospacing. So let's say 50% of electrospacing. If you use like a 10-meter electrospacing, so your maximum resolution 5 meters. So keep in mind that, so that like if you're looking for objects or thickness of the layer is about 2 meters, and then you should put your cable electrospacing 4 meters in that case. But when you put shorter cable, you have a shorter depth of investigations. If you have larger electrospacing, you get deeper, then you get less resolution. So how you can manage in this, you want to also deeper investigation, but you want to also higher resolution. Then we will suggest in that case use multiple streamer. I will talk about that, what multiple streamer, how we can design that also. In our new generation SuperSting Marine Wi-Fi system allows you control your data on the field with SuperSting Marine data, but SuperSting Manager applications. You can control the data stream in the real time and the boat when you're towing your cable, and you can control your data quality meantime while you're measuring, and you can also plot your all results in the when you're in the field. So you make sure that your data quality control is done during the field data acquisition for the time. So that will save your money and time. If you do some mistake, some error in this kind of the studies, as you know, you need to go back and repeat. So that's sometimes not possible or costly. So to make sure that your data quality is be controlled and done very well in the field. So that's what we try to make it easy for you to use our Android applications, SuperSting Manager applications in Android device to control your data quality in the field. So here's application features for especially for marine. The same application can be used for land. As you know, you're using mainly land, but in the marine, we put a little bit more features on this. Like you can plan your survey before going to on the field. So that means you put your map and tracking the line orientations and the boat track directions, and you plan this to put it, and then you start simulation on this before going it, and then it will help you also with the navigation once you prepare this your track, and then you can observe your tracking and control your navigation through the application, and it will help you to correct your if you're out of your navigation, as in this case is it will correct you in the put in the right track in the studies. And also you can do your route optimizations, and you know in the marine, in this water environment, you don't have references, and the only thing what you have a GPS and positioning. So you need to know where you're going, how you're going. You're not going to cross the line. Maybe you're doing multiple going and up and down, and then turn, how you're going to be from one line to another line. So you can optimize these through this application. And also you will see all your, as you can see here, is there are 8 levels of measurement. You can see the real data while you're measuring. So while you're measuring, you see all your data continuously like this, and it will plot the data and depth and also water temperature on the same plot. You can control also that I'm in the let's say statistically all these in the data, how you're the tracking, orientation, in all this statistic information will be available on the applications. So you can control and correct all these in the tracks and everything in this application. So you can later on also play back all these what you did on the field. So it gives you lots of the control on the field using this feature of the manager applications. Okay, let's go through this the type of the measurement. So what I said, you can do stationary measurement and then dynamic measurement. What I mean stationary measurement. So when you're in the field, like the land, let's say land studies, what you're doing, you're static measurement, stationary measurement. You put your cable and then set up your measurement protocol and then push the button measure. So you're not moving. So that's, you can do also this on the sea, or while you're moving your cable, like 2-3 kilometers up to 10 kilometers per hour, you're moving, you're pulling your cable, and dynamically that means you measure. So every 3 seconds you inject current, you measure continuously, you're doing this. So what we call this dynamic measurement. So like let's start with the stationary measurement. So stationary measurement you can do generally 2 way. First is you put all your electrodes, multi-electrodes. Is typically this number of the electrodes is starting 11 to up to 56 electrodes. One section. If you're in the middle, and you can also put another side. For example, if you're in the boat, and if you put on the one side is 56, another side 56, you can put total 112 electrodes. Or if you're on one side, also we can make special cable for you. You can put 112 electrodes just all one side. So that means is that there are options of doing this. Because why 56 electrodes? Because our standard cable comes with 56 maximum 56 electrode available on the one cable. So if any special interest in, we may consider for different number of electrodes, but keep in mind that standard system up to 56 electrode for one cable. So you can flooding this top of the water surface, as you can see here. How you can flood it? If you just drop the cable, it will just go down under the water. But for floating material, you can just put it like a small buoys or some the swimming pool floating material, like the kids are using it. You can just tie up your cable and start floating your cable top of the water. So here, like you can get 2D studies, you would just move the line and then make 3D studies like this. So on the top of the surface, and you move your cable, measure statically, and then move next line, measure, next line, measure, and then combine all these parallel lines, make a 3D imaging. That also you can do like easily, and such an water environment and the floating on the cable on top of the surface. So that will be easy to control, and then put easy to also the straight line on the cable. The other thing is you can just pulling your cable inside the water. So with a boat, you're pulling your cable and then just drop the cable from the boat, and that will cable go through under the water. So just make sure that in this case you go straight line in the boat. It's not easy to go in straight line in a boat. So you need to somehow get a reference point to pull your cable straight. Otherwise, you make a snake shape of the cable. So that is not recommended to do. So you need to try to put straight, more or less straight on the line. It's not like a surface you can just pull it like this, but under the water, you need to try to do that. So you can put your cable, whatever your water depth is, the cable can be manufactured for different lead in. So I always ask the client, so what is the, what kind of the water environment studies you're trying to do? What is your considered depth first? And also, what is your water thickness? Depending on the water thickness, if you're trying to do underwater studies like this, you want to put your cable under the water, then I need to know what is the water depth. That means we can put sufficiently cover to all the water depth for the lead in on the cable. Okay, so there, whatever is maybe like 1,000-meter water depth you have, okay, then we can put lead in 1,000 meter, and then you can have here is like a 56 electrode, like a whatever electrode spacing you want, we can put it. So our cable can be dropped down is like almost 2,000 meters under the water. So that pressure and then the temperature can handle that intervals. Second option is the dynamic studies. So dynamic studies also can be done two ways. The first way is you tow your cable top of the water. Okay. So remember, for towing measurement, dynamic measurement, each time you need to use 11 electrodes. First 2 electrodes is current injection, okay? Next 9 electrodes will be voltage electrode readings. So what I mean is you inject current A and B and then measure P1, P2 like up to P8, P9. So 8 level of measurement can be done in this towing way, towing 11 electrode each time. So if you have a multiple streamer, then you want to do towing. First, you tow 11 electrode, another 11 electrode, another 11 electrodes. So I will show you short of that how that streamer is. And this will, in this case, and if the water thickness is shallow, yes, you can cover in some depth. But if the water is thickness is very deep, and maybe in this your towing cable not sufficient to cover, then we become like a short in depth of investigation. So then all measurements will become in the water column. So in that case, what you can do, you try to tow your cable close to sea bottom. Okay. So the technique is in this one. I never done it, but some clients has been using this technique. This can be let's say not easy to do that. You can just tow your cable close to sea bottom, as lots of the obstacle can be tackled, and the cable can be stuck, and it is many difficulties sometimes. So sometimes you need to tow it not on the sea bottom but close to sea bottom to get better data coverage on the depth of investigation on the under the sea bottom actually. So we have like a design of this like a very deep and studies also you can do with this the cable with the withdraw remote submarine for control for this kind of cable movement on the deep waters. So again, and you can tow on the surface again with like a buoys, a floating material. Cable is hanging on the top of the water, or just dropped under the water with some fishing material, some floating material, navigation material on the beginning at the end of the line, and then it will help you to pull your cable in that certain intervals. Okay, what I said is that typically you use in this marine studies dipole. But dipole is what we suggest to use with our system. In the market, you may see, or some of them you may have different instrument. I don't know, but most of the other instrument manufacturers, they don't recommend doing dipole. They do inverse Schlumberger. They recommend to doing gradient or Venner or Schlumberger. So those are like is not very adequately useful for this marine studies. the best marine studies array type is dipole-dipole, or you can also use pole-dipole, but mostly dipole-dipole. Why? You have a current is in the beginning very like a close each other, and then you start moving, and then you measure. If you do Venner, you're stuck with this one single channel measurement. If you do gradient, now you have a current in beginning at the end of the line, and also that you're trying to measure in the middle. So like, it's not like geometrically is not the same sensible information, like a high resolution information you will get when you use dipole-dipole. So dipole-dipole is the best array type to use in this kind of the studies. But we always also recommend the dipole-dipole, not only marine, also the land. So because we know our system is very high resolution receiver and capable of get very good dipole-dipole measurement. So we trust our system, and then we believe our system. Then that's why we recommend to do dipole-dipole to get this best resolution. Even if the dipole-dipole is poor signal, but has a best lateral resolution, and then you get a very good data coverage with this in fast way. But if you want to get sometimes deep studies, you may also to use pole-dipole. We can do like a marine cable, like in the dynamic mode measurement. Just maybe one electrode is in the further away and some distance away. That will also give you some deeper investigations. Okay, like earlier, as I mentioned, is just you have a first 2 electrode here is the current injection, and then next 9 electrodes will be 8 level of measurement. So you move like your um, board, and then you start measuring 8 level like this. So continuously you get like this measurement. Okay. Okay. What if you want to do is use multi-electrode marine streamer? So here I to make a sketch of the like a 1A electrode spacing, 2A electrode spacing, 3A electrode spacing, and 4A electrode spacing marine streamer. Here you can see like a 28 electrode total. When I use this, like a first here in the first one is 1A electrode spacing is 11 electrode. Okay, so first you put these are here as the anchor points. You put this anchor point, connect to the cable. Rest of the cable will be in the boat. So you start pulling your cable from here. When you start pulling here, then you have a very shallow investigation and high resolution measurement. This 8 level of dense measurement you will get. But you see that you want to get deeper, and then now you can come back same line, try to go the same line, and then now change the anchor point connection. Now you have also you change adapter on the instrument. This kind of multi-streamer comes with different adapter, or one cable come with switch box. You can just make different command file for this. So either you have a multi-electrode, let's say if you have a special multi-streamer cable, or you can have a multi-electrode cable, marine cable, like let's say you have a 28 electrode or 56 electrode marine cable. You can also manage this to use the same cable for underwater study and also for pulling in such way different electrode spacing measurement. So this will in 2 electrode spacing, 3 and 4 electrodes in this case, you'll get like a different depth and different resolution. You can see that here's the first one is high resolution, and green is like resolution decreasing, yellow is less, and then blue is less, but you get deeper. So that means it's the resolution sense, and you need to consider in this way also. Okay, resolution and depth. So this is the same thing you may think about it for land studies. Same thing, resolution, for shallower electrode spacing, shorter depth of investigation. So in this multi-streamer generally is we put this where the current injection will be graphite electrodes. The rest of them will be stainless steel electrodes. That will be cheaper. But if you put everything in the graphite, it will be a little bit more costly, nothing else. But it can be used for any combination. Other option is to use a deep ocean bottom study. So we already designed this OBE1 system. Here is in this is the can be used up to 1,000 meter depth of investigation. Um, there are studies, and I will show you some case study on this one for gas hydride studies. In this particular study, and then we designed like a 56 electrode graphite multi-electrode cable and 20-meter electrode spacing. And this same like a SuperSting, same features, everything on this OBE system, OBE1 system. And this can be just go through with this row system, remote control machine like a row, the submarine, and you just lay down under the water and then just try to control and measure. Other option is to use external transmitter. As you know that SuperSting has a 200 watt power output. So that means instrument is capable of injecting 400 volt, 2000 milliamp current injections. But sometimes very deep ocean bottom studies or let's say very deep studies, especially in the deep ocean bottom studies, you may need to inject more current to get deeper studies, deeper information, let's say. In that case, you may use also SuperSting Marine together with PowerSting, which is PowerSting external transmitter. We have a different version of this, like a 5 kilowatt, 10 kilowatt, and 15 kilowatt. For example, is the 10 or 15 kilowatt is the 10 kilowatt is a low voltage, like a 300, 400 volt, and 27 ampere current output version of this PowerSting together with this SuperSting for deep studies can be done. Okay, there are two options of doing this. So you can put your PowerSting on the boat. Okay, here's you can see A-frame. You need the A-frame boat on this because in order to able to lift and then put these heavy cables and a system under the ocean, control everything, and tow this very long cable sometimes. So you need what we call A-frame on the boat, like a winch, and this can be our standard system come 1,000 meter. If anybody needs in deep studies 2,000 meter, now we need to consider also for modifying this for a better high pressure deep studies system. The multi-electrode cable can be like a multi-streamers or multi-electrode like a 56 electrode. Okay, in this case, let's say if you're wanting to do is like a deep studies with the PowerSting on the board, SuperSting on the board. In that case, I can put all the cables like a 1,000 meter lead in, 2,000 meter lead in, another like a long cable on the bottom. Or I can leave it to PowerSting on the board and SuperSting like here on the bottom. And in this case here, we need to separate this current cable and voltage cable because of high voltage on this one, and has to be separated. So then we can use the voltage cable like behind the towing this OBE system, and then the current will be injected through this and at the beginning. So in this case, we can also make special configuration, not dipole, maybe pole dipole can be easily to do deeper and investigation in this case. So that's also possible to use high power output on this kind of studies. Here's an example of that is typically is used for this is deep ocean bottom studies for gas hydrate. So here's a 56 electrode and 20 meter electrode spacing. It's about less than 150 meters depth of investigation. It can be reached on this one for somewhere the gas hydrate study, gas hydrate intrusion zones in the BNC. Okay, I'll show you some examples as what examples we can see. Here you can see this is like this is the picture come from Panama Channel. This is a long time ago. It's done. One of my colleague, and again that's just towing 11 electrode, and this picture come from there, but this is another and from Florida actually. You can see here like a boiling spring in this study area can be found. Um, one consideration on this kind of marine system is turns. So if you're continuously measuring, when you come to the corner, you're not going to measure on this one, but you can keep measuring always. So later on, we need to um, process the data. I mean, you need to cut the line from straight line. You cannot get this corner of the measurement because one of the electrode on the this side, another electrode here. So 90 degrees, it looks like it's not a straight line. All measurements should be like a straight line consideration. That's why like when you go turns and then keep measuring on the turns, or you can just stop measuring and then let's say this is your survey area, okay? And or this is your survey area. So like you measure here and then you just stop of measurement and then you go all the way out and then come back. When the line is again straight line, start measuring, okay? You can do this kind of the things or keep measuring, and later on the we have a software, Marine Log Manager software, process the data and also just get like a straight line on this way. This is the Marine uh, Log Manager software processing the data. You can read your data, you can read your GPS data, and you decide which interval you need to get. And straight line, you calculate that for linearize of the data for let's say synchronizing with GPS and together all your measurement, and then get this data, and that will be saved as a STG file, GPS file. I mean, sorry, STG file, GPS file, and also the DEP file. All right. So processing will be done on the Marine Log Manager and this kind of towing survey only. Stationary studies, there is no need. And stationary studies or marine studies in general, you need to, if you have a, let's say, topography, you always have maybe you have a flat bottom, not topography, but however you have a water thickness, right? Or you have an uneven bottom, or you start your survey from land to water, water, land like this. In each different scenarios has a different type of the underwater terrain data format, the underwater terrain format. So that means there's an examples on the user manual of Earth Imager. You can find these examples and you can just use whatever is the corresponding your study and prepare your underwater terrain file for this one of these cases, and then read your data, choose your default setting, and like a CRP measurement or salty water measurement, freshwater measurement, and Earth Imager 2D has this kind of the default setting options, and then read underwater terrain file and start inversion. So inversion process is easy. So like once you do this prune your the data, so that means once you linearize your data after synchronization with GPS, and then when you save it STG file, and then you do now prepare your underwater terrain file, and then you just do like an inversion. So when you have, since you have a let's say if you have a dynamic and long line, and in this case it's not possible sometimes to do whole complete line one inversion. It's too long, so not sufficient memory in the to handle it. So then in that case you need to use CRP modular on Earth Imager 2D. So what it does is divide the data in subsections. So this is your complete data set, and then make like a subsections, and then these subsections will be inverted separately, each color zone inverted separately and combined, and at the end you will get continuous one section. Okay. This is another example is, for example, river crossing. So like you can see this, the cable start from land and going to under the river and then going another side. And then you can see that land and water environment study can be done. Here you can see like a fracture zone under the river. Here's another example from starting from uh, the shore, just on the beach, and going through to this in the water, and then cable actually starting from land, the water, going all the way the land. So in this case, for example, here they used in land cable and water cable separated, but you can use all together also. So as long as you have a capacity of the number of electrode your instrument, and that means is like your instrument, for example, 56 electrode capacity, then maximum you can use 56. If you have 112, then you can use 112, depending on whatever your capacity. Maybe you have a marine cable 56, then your instrument capacity 56, then you have to do separately. Another example also from land to water, and then just looking through this fresh water spring, and you can see this and under the water, and try to find also the freshwater discharge areas under the water using the marine cable. This is another example come from our office side. When we do marine seminar in the office, we have a lake and then next to our main office where we do this all this kind of the uh, marine seminar practice on this lake. So you can see here underwater cable measurement. Here underwater is just a go through under the lake, and then just make this measurement. So when your like a boat is moving and the cable is just dropping down, so like in this case cable goes straight. Another one is, this is also is done in with the dynamic studies in the Panama Channel, is like a very long like a distance. So like dredging companies really wants to know in this kind of the rivers and channel, the Panama Canal and in areas and the harbors, they need to know dredging how much that the accumulated uh, the material like a mud or uh, deposit in the area, the cleaning up for digging for because of this material is like a accumulation is um, like obstacles for navigation for the big ships. So in this case they need to clean up time to time, so they need to work dredging for these purposes. And then the marine studies, this kind of marine studies, it really helps to dredging companies. This is another CRP measurement for just you can see I just showed this to, you can also see here the temperature line and the top, and Earth Imager 2D not only shows the distance, and also you can see on the top of the coordinates like a UTM coordinates or latitude longitude coordinates on the line if you want to do it. And you can do also 3D, like as earlier I showed this same picture. You can do multiple lines like this, and at the end you can do like a 3D image. And in this case, you need a Earth Imager 3D to combine these multiple parallel lines to make this 3D image. So this is the study on this lake, and it shows here when the fracture zones where the water charging areas in these points. The another example is like a kind of the pond, and there's a leakage studies. So you can use also the marine cable in this kind of the leakage studies. So if you have a linear like this, you put like a one current inside, another current outside of linear, and then just get the voltage, the differences. You do manually or automatically. If you have a two linears, and then for the outside of current will be between the linear, where the leakage can be controlled, because current will flow through from here, and then those where the current crossing will be like a 0 voltage. Then you will have a negative positive voltage around it. So that's the point you're trying to find actually. Here, let me show you this, the cable. You just start moving, and then what you have here, you will see this like a here, this point, just for where the leakage is. So you need to move your cable, make this automated measurement, and then combine these parallel lines, and then to make this all together. Uh, okay, let's go back over here, and then make this plotting the voltage contour. It really shows you positive, negative changes point and 0 voltages where the leakage will be. The last example is also related to water environment. That means our marine cable is same for use not only for uh, towing and not only for sub-bottom water studies, but also in the boreholes. Sometimes some boreholes can be uh, dangerous because can maybe collapse or stack obstacles, and sometimes doesn't, because borehole has to be saturated with water. If doesn't saturate with water, you need to fill with the drilling mud. If there is a drilling mud also escaped, then you need to put cement. In that case, the cable will be permanent in the borehole, so it's not permitted. Well, you're not going to use expensive our borehole cable. I mean the spending money and then leave it in the ground. So in that case, you can use disposable, like kind of the homemade cable style, like you use PVC, put clamps every intervals, and then get a cable from each clamps, and then pull all this cable out, and then that's really easy to use our switchbox grid in this kind of studies. So we designed switchbox grid to use your kind of disposable cables, your own cable, to just plug in directly for every electrode here. For example, this is 56 electrodes starting from 1 to 56 plugs, and you just start plugging or on the order of the number of electrodes. So you can use single borehole, cross borehole. So remember, the borehole has to be saturated. So sorry, the saturation can be water or mud or any other material can be holding in the borehole. Then you do your cross borehole studies. Okay, this is typically our systems, and you know, but I just want to show it again. Here's the manual mode, mini-sting, low-cost instrument, and SuperSting different versions. Deep ocean bottom studies, comes with marine module, comes with remote module, comes also with the external transmitter, and this is the switch box kit what I talk about shortly. This is SuperSting node and can be used for automated high voltage current output, like a switch boxes. These are our softwares and also our electrodes. Remember, we manufacture everything ourselves, so we don't let third manufacturer to do manufacturing like a low standard noisy cables. So all our cables made in our house, made in our technicians with our high standards. So that makes guarantee to you to get a good data in the field. Well, thank you so much, and I'll now check the question. But I received one question from through the email. So here's the question: what is the maximum current to inject? Okay, the SuperSting has a 200 watt power output instrument. So it has a maximum 2000 milliamp current injection. So the marine water environment is the only place that SuperSting can inject 2000 milliamp. On the land, and then you cannot inject 2000 milliamp. So everything depends on your contact resistance. So like you have a lowest contact resistance in the saline water, so where you inject in the highest current. Okay, that's like a 2000 milliamp. So what is the, well, if you use an external transmitter, power thing, 5 kilowatt, 10 kilowatt, 15 kilowatt, then depending on the which version you're using, you can go maybe 27 ampere current injection in that case. But believe me, that's 2000 milliamp is, you have seen example for deep ocean bottom studies, like 800 meters in water column, and then 1,600 meters cable length, and able to use for 2,000 milliamp current injection, able to get about 150 meters depth of investigation, more or less. So what are the constraints that can disrupt the mission? Okay, in the marine studies, is the important is positioning. So that's like we try to help through our application to get correct positioning, and then correct your the tracking and many things. It helps. But part of these difficulties of positioning is important is the data acquisition in the heavy wavy marine environment. If there is lots of waves in the marine studies, when you're pulling your cable, there are lots of waves coming. In that case, what happens is your cable start, some electrode maybe will be in the air, some electrode will be in the water. So that will create noise. Another thing is in the heavy waves, when you're pulling your cable, sometimes the wave is stop you almost, and then sometimes you pull you very fast. So you're like an irregularly spatial distance in the measurement also. The other thing is, if you're doing studies in the harbor, that happened one of my clients. They were doing the harbor side. There are like a big ships is moving around, and then they start measuring in the underwater cable measurement. Suddenly, like one big ship start moving, and then lots of turbulence in close to electrodes. That also creates some noise in somehow. So you need to be preferable calm water environment to get better data. So what it is resolution of these studies? Well, resolution is typically what I said is the half of electrode spacing. So that means if you use electrode spacing 10 meter, your resolution 5 meters. So that means everything related to your electrode spacing. So whatever electrode spacing will be, that's half of it. That will be your maximum resolution. Okay, let's go to another question. Let me try to get this, if I can get it. Copy. I'm trying to copy this. No, well, anyway, his question is, I can see maximum electrode that can be used. Okay, maximum electrodes is, as I said, is we have a standard cable now is maximum 56 electrode can be manufactured under one section of cable. So like you can use in more than that also, but then we need to put in the in every sections 56 electrode maximum. Okay, let's put it that way. But the maximum electrode can be more than that. So that means I can put multiple sections of cable. Now I have a more than 56 electrode measurements, so 112 maybe or more, depending on how many switch boxes we're putting. So as you know, our system capable of to use up to 65,000 electrode numbers, but practically is not possible. No, that practically I know is some clients has maybe maximum 450 electrodes. So far I know. Okay, the another question is, for 27 electrodes using dipole-dipole arrays, what will be the maximum and minimum penetration depth? Okay, again, this is the 28 electrode, depending on the electrode spacing. Let's say if you have like a 10-meter electrode spacing, so your cable is 270 meters. So just remember that. So what is your total cable length? Try to get about 20% of that. So 270 meters, and then if I get 20% of that, so 54 meters more or less you can get with that cable. So it's sometimes you may get a 16%, sometimes 25%. When you use a dipole gradient Schlumberger type of the arrays, but when you use the pole dipole, then that will be increasing to about 35 to 40% type of the total the cable length. Okay, so depending on that electrode spacing and then also the array type. Okay, another question is, how helpful is Schlumberger inverse array on land survey? Which array is more preferable in land survey? Okay, if you have a multi-electrode system and multi-channel instrument, recommendation is 100% dipole. Okay, if you don't have our system, if you have another system, that system cannot able to get good dipole measurement, then okay, you can do maybe inverse Schlumberger. That will give you maybe about 4 channel of measurement for every current injections. But if you have our system, highly recommended to use dipole because our system gets best dipole measurement. Okay, what is your experience with the resistivity cross-hole measurement? What is the maximum distance between boreholes? And finally, this is the kind of measurement could be done by SuperSting, or do we need specific equipment? Many thanks in advance. Okay. Sorry. For borehole studies, is the rule of thumb is the borehole spacing depending on the borehole depth. So the ratio is 1.5 more or less. So let's say if you have a 100 meters borehole depth and another borehole about maximum like a 60 meters away, 66 meters away maximum. So that's if you get more separated, then you lose the information between the boreholes. Okay, so that borehole separation depending on what borehole depth you're using it. Okay, so okay, rest of questions. SuperSting, yes, you of course you can use our SuperSting. You don't need another specific equipment. As long as you have an instrument, what you need only borehole electrodes. If you don't have borehole electrodes, and as I said, and you can use your your cable, like a your own made cable. Just show like a last example, and a disposable cable, you can do that with that one. If you have any further information on this, just please let me know. I'll send you. We can explain that also a little bit more. Okay, another question. If the survey is for combination of land and marine, and what is the maximum current injection? So the current injection it doesn't matter mixture of land, marine, and everything is the current injection depending on the contact resistance. So of course, when the cable is, when you're injecting current on the land, and current injection will be less because you have a higher contact resistance. When you handle the electrodes on the water, when you're injecting from the water, and then you have a lowest contact resistance, then you inject higher current injection. So on the land side, maybe you inject, let's say, depending on contact resistance, let's say 500 milliamp, and the marine side you will inject definitely 2000 milliamp. So that's all depending on the land side contact distance. Okay, another question, how deep is affected by floating the cable and putting in the sea bottom? How depth is affected? How depth is affected by floating the cable and putting in the sea bottom? Well, is all depending on if you want to put your cable under the water. When we need to put this lead in on the cable for that corresponding water column. So whatever water depth is, And then if I want to put it under the water, then we need to manufacture cable in that purposes. So we cannot later on add cable, put connectors, because connectors is even if we use high pressure marine connectors, special connectors, and it may filter water depending on the depth. So some uh, connectors, special connectors available, but depending on the water depth, some of them is very shallow water depth, cannot be used for deeper water depth. So that's why it's important to use one entire cable is in the let's say um, lead in, long lead in for the cable. Okay, okay. For three-dimensional survey, what should be the minimum inter-electrode spacing? Well, three-dimensional survey, it doesn't matter land or marine. So our recommendation is, the best 3D image, and your line spacing between the parallel lines. Line spacing is maximum of electrode spacing. Let's say if you use like a 5-meter electrode spacing, okay, for one line, and then next line should be maximum 10 meters. That will be give you perfect 3D. So what if you do more than 10 meters? So that means what if you do more than twice of electrode spacing? Well, you may lose some information between the lines. It's not a real 3D. That will be still you can get 3D image, but you may lose some information between the lines. Okay. Okay, let's see. Another. Can I IP survey conduct? Yes, sure, of course. You can do resistivity IP. If you want to do IP, yes, for especially some sorry, some interest of some clients is for deep ocean bottom studies, especially for oil and gas and mining investigation. So in some areas, for example, oil studies in salt domes in the area, there are some um, chalcopyrite is like kind of the conductive mineralization zones. That will be really good to do for resistivity IP, because those high conductive mineral zones gives you high IP, high chargeabilities. So if you'll get a low resistivity in most of the cases due to water column and then the mineralization, but when you do IP, then you will get a high chargeability from that zone. So that will help also to describe for mineralization. So you can do that. Answer is yes, you can do resistivity IP. Okay, another one is, can we use system in very fresh water? Do we expect electrode resistance? No, you can use very fresh, even if you can use bitter water. So the water environment is much better contact resistant than land. So if you're doing land studies, I got a client use land studies about 500 meters, 1,000 meters depth of investigation with same instrument, SuperSting, 200 milliamp current output. Okay, we are using AGI SuperSting and perform Schlumberger inverse array. It takes less acquisition time. How is different than Schlumberger array? Okay, if you have a single channel instrument, so it doesn't matter. You can do Schlumberger or inverse Schlumberger. But if you have a multi-channel instrument like a SuperSting 4, SuperSting 6, SuperSting 8, then okay, inverse Schlumberger is fine. The result will be similar to Schlumberger actually. Okay, but if you're doing vertical sounding, so just keep doing Schlumberger directly. Okay. I just missed one question over here. I got many questions. Wow, that's great. Okay, hold on. I'm trying to sort these questions. Okay, can these be used for detection cavity, limestone, other carbonate? What will the maximum practical resolution that can be achieved? Yes, of course, and please just visit our case studies in our webpage. You will see lots of case studies that will show you many different cavity studies and freshwater studies and marine studies, mining studies. Of course, you can use for cavities because it's the resistivity is one of the best technique to give this kind of the fracture and cavity studies, in special limestones. There are like very, very fantastic results you will obtain with this. You can use it definitely, no problem. How can be near the harbor? Okay, the harbor is what I said earlier is a calm water area. There's not like lots of the turbulences affecting your the stuff. There is no also any let's say grounding in the area. That's grounding is one of the considerations sometimes. But in the harbor, there's not much grounding actually. But what happened is in the harbor is closed water environment, very shallow, maybe like 10 meters, 8 meters sometimes, no, or maybe more. I don't know, maybe less, depending on the harbor. But if you're moving as measuring suddenly passing with a big boat and then with the helix makes lots of turbulences, moving all material around it, that will create noise on your data. So that's the only concern I should think about it. Part of that is if you're doing towing survey in the harbor environment, that's not easy because of the harbor is very short distance. It's not easy to do towing a long cable long distance. Okay, which array should we choose for cavity void detection? Again, is dipole. It doesn't matter what I'm talking about, resistivity in marine or resistivity land, resistivity except borehole. Just use dipole. You will get best uh, lateral because whatever you're studying, you're looking for lateral variations. So lateral variation best sensible tool is the dipole. So just keep using dipole with AGI system, SuperSting. If you don't have SuperSting, then you got trouble. Don't use dipole. Maybe you need to use another. Like most of them recommend doing gradient or Venner because they are not very sensible receiver. They have to get good dipole. Okay, please arrange webinar and IP and SP survey. Sure, of course. I will pull this poll. Okay, I'm just launching this poll, and then you can put this voting on this. I should have put that before, but I just launched this poll, and then you put mining or whatever you want to do it. Okay, resolution, vertical resolution, horizontal resolution, sample acquisition interval, and electrode separation. Okay, maximum voltage and seawater. Okay, this is another question. I think this is the almost last question. Okay, before the last. Okay, the resolution, vertical resolution is the depending on electrode spacing. So maximum vertical resolution, half of electrode spacing. So 1 meter electrode spacing, then maximum resolution will be half a meter. Okay. How about horizontal resolution and for marine studies? So that will be like a if you're going too fast with, let's say, let's consider dynamic measurement. If you're moving too fast with the towing the cable, so your sampling interval will be a little bit larger. If you're going reasonably slow with the boat, as long as much as slow, no, slow as you can go, you get horizontal variation sampling rate is very close each other. So that means you're covering like a special variation horizontally is uh, very often from one point to another point. So in that case, you will have this good data coverage in laterally. But in the resolution sense, consider always is it doesn't matter is in the vertical or horizontal is maximum resolution half of electron spacing. So if I get like a 1 meter electrode spacing or 10 meter electrode spacing, then my maximum resolution 5 meter. So in this case, if I moving my lateral resolution is like a half a meter, because of every half a meter maybe corresponding 1 data points. So that doesn't increase my resolution, that only increase my data coverage in the laterally. Okay, but in the resolution sense, could be maximum electrode spacing, half of electrode spacing. Maximum voltage and seawater. Okay, that's good question. So what we are SuperSting, you can use maximum 400 volt for 2000 milliamp. That will be for maximum you will use. For example, if you're using the external transmitter, for example, we designed the external transmitter 1000 volt, 2000 volt, up to 3000 volt. But in the marine studies, it's recommended to use 375, 400 volt in external transmitter, and then high current output, like a 27, 10 ampere, 20 ampere, 25, 27 ampere current output. So let's consider like a 400 volt, 27 amp for when I use SuperSting 10 kilowatt. Okay, if you use mid-depth streamer, how do you separate the current that travels horizontal to the bottom and the parallel streamer? What I am mean currently will propagate. Okay, try to understand the question. I will read one more time. Sorry. Okay, this is the, if I use a mid depth streamer, how do you separate it? Mid depth streamer. Okay, so like I see what you mean. How do you separate the current that travels horizontal to the bottom? I see. Okay. So the question is if I put the towing my cable inside the water, okay, and maybe close the sea bottom. So my current goes to an up and down. So you're typically the same thing when I lay down my cable on the sea bottom. So that's like you have a water column top of my electrode, and maybe some water column on the bottom, and then uh, the lithology on the sea bottom lithology. So the current always goes anywhere. So except in the water surface, it doesn't go air, it goes in the water. But inside the water, now it travel goes to the current outside of inside. I mean the top of the electrode inside the water and the bottom. So that doesn't really matter with depth of investigation. So that depth of investigation is, as much as the current goes up, the same amount will goes down also. So like your depth coverage will be the all related, will be the total cable section, like 100 meters or 200 meters. Only thing is solution in the 2 pi or 4 pi, because in the full the sphere is a half a sphere, and depending on the water surface is half a sphere. In inside the water you have a full sphere, in that case like a 4 pi, and the calculation of the apparent resistivities in that case. So but um, in the current will be the same, travel goes up and down same, doesn't matter, but you don't need the current going up, because what you're measuring is coming from the bottom actually. So that's like an influence. Okay, so that's always sometimes what we call it is like a omnidirectional. So what you're measuring, you're coming from all around 360 degrees, but as in the all around in the water column will be this homogeneous material. So what we are looking for up on the bottom is in the heterogeneous material. So when I measure it and I have a homogeneous material corresponding water column, and then underneath heterogeneous material under the water. So that's what we're trying to find it. So when we plot it, that what we need interested in the bottom of this the heterogeneous materials under the water bottom. I think that answered that question. Okay, there's another cavity detections. Yeah, the same thing is I answered that before. I think maybe you missed that part, but you can still use the dipole, okay, for SuperSting to this kind of the cavity detections. Okay, how does the experience factor change depth of image? Expansion factor. For that's all related to let's say the geometric factor is all depending on array, the array type. So that array type, what we're recommending is dipole. So dipole is like what your depth of penetration with that. In the marine, you will get about saline water environment, 15% of your total cable length, and then 20-25% on the length studies. So that's just considered that way. That will be, you don't need to consider for different geometric factor, expansion factor. Okay, I think that's all. I got the questions so far. Okay, one last question. We already passed the time now, but one last question comes. Contact resistance maximum time, try to overcome putting salt water around electrode. Okay, we're talking about now lens studies, I understand. Yeah, well, I'll try to send you email, but let me just briefly explain. Contact resistance can be lowered down on the lens studies, putting water, salted water, or you can put also the bentonite solution, and you can put more than one electrodes, stainless steel electrodes, and you dig the ground a little bit, pour more water. Try to reduce the contact resistance on the land if you have a high contact resistance, especially if you're doing mining IP, resistive IP studies for the land. Try to put contact resistance less than 1,000, less than 2,000 ohms or 1,600 ohms. That will give you better IP measurement. Okay, otherwise you will get like some noisy IP data. Is like if your contact resistance very high. So this is the technique that pouring water, salty water, or bentonite solution will reduce to your contact resistance. Well, thank you so much for joining me today for this webinar. I see lots of people attended during this and lots of questions. And if I miss any question or couldn't answer properly, please just send me email. I'll try to explain better way, try to make it. And thanks for also voting for the polls. And I see many people interested in different things, and we will try to consider on this and then manage next time for our webinar. But I wish you all best in without COVID-19 issues. I hope we all together is get over this problem soon, and then try to be in normal again, and then make all the business helpful each other. Thank you, and have a nice day. Bye-bye.